Welcome back. Please make sure you have this video split screened with your chemical interactions must do Limewater reaction notes. These will be filed under Science Journal and will be submitted later in Lesson 2B. So in the past, we've learned that sometimes elements survive or move around the universe alone, and sometimes they combine to make different compounds, and they do that through bonds that are sometimes weak and bonds that are sometimes strong. Like in this picture of sucrose, the bonds that are stronger are the dark red carets, where the bonds that are weaker are dashed. The picture on the left is a picture of sucrose with the 3 different types of elements bonded in a 3-dimensional type of model, and on the right is a picture of sucrose, same thing, but showing the bonds that are weaker and stronger. In this case, the elements combine to make something much more complex together called sucrose, or we know a common name as table sugar. So we're going to look at sugar in 3 different ways. We're going to look at it dissolving, we're going to look at it melting, and we're going to look at it reacting. And in each of these cases, we're going to discuss if a chemical reaction has happened, if the sucrose is somehow changed to become something new, somehow break the bonds. Will that happen when I dissolve sugar? Will it happen when I melt sugar? Or will it happen when I combust sugar? Stay tuned for the answer to those questions.
Have you ever wondered how sugar dissolves in water? It actually has something to do with the way the water molecules interact with the sugar molecules. When you first pour sugar into a glass of water, the sugar is still visible. This is because the sugar molecules have only just been exposed to the water molecules. They have not had much time to interact. The sugar molecules are still attracted to each other. As the sugar is stirred into the water, the sugar seems to disappear. But it doesn't really disappear, does it? No, both the sugar molecules and the water molecules are still present. The reason the sugar seems to disappear is because the sugar molecules are more attracted to the water molecules than they are to each other. When the water is stirred, the sugar molecules mix with the water molecules. The water molecules insert themselves between the sugar molecules and begin to surround each individual molecule. The once clumped together sugar molecules are now more attracted to the water molecules, which is why they easily separate from each other. When the water molecules surround all the sugar molecules, the sugar is dissolved.
So in that last video, we talked about dissolving first. Dissolving, was that a chemical reaction? No. Dissolving is just a mixing of sugar and water together. Mixing is not the same as a chemical reaction. So what about melting sugar or burning sugar? Will that cause a chemical reaction? Follow along in your notes with the questions. Is the sucrose still sucrose when it melts? When you melted sucrose, you immediately took the spoon off the flame. What will happen if I leave the sucrose over the flame? When we melted and dissolved sucrose, we still had sucrose. Do we have sucrose anymore? What is some evidence of a chemical reaction? These questions should be answered as you watch the next video. Please pause the video as you learn the answers and write in your guided notes. When do we break the bond of sucrose? In the last video, we melted sugar and then we burn sugar. Burning is a chemical reaction in which a brand new substance is created, a new product. I can tell because there was a color change. I can tell because there would have been an odor smelling kind of like sugar or caramel. And a new product was released. Energy was released in the form of heat. You saw the smoke. So burning is a chemical reaction. Melting is not. Another familiar chemical reaction that relies on burning takes place in fireworks. Have you noticed the image on the front of all of our slides? When fireworks are lit, specially planned substances burn to emit colored light and smoke, among other things like noise and definitely odor, a smell of sulfur in the air. Each one of these different fireworks is a different chemical reaction, with the evidence being combustion, color change, odor change, and definitely temperature change. In the past lesson, you learned that little elements alone are called particles, and sometimes particles are just one element big, and sometimes particles are multiple elements bonded together. What happens to these bonded particles during a chemical reaction? What happens to their bond? This is the question for the following experiment. Please follow along in your guided notes. Let's review the mystery mixture. What evidence did I have of a chemical reaction? First thing we all noticed was that there was fizzing, like Sprite, or a gas being made. Next thing we noticed was that the color had changed once I had evaporated the water. For example, ascorbic acid was yellow. The mystery mixture had a temperature change. It became cold, where its challenger became warm. And in the case of the fireworks, there was combustion, or fire being made. So examples of chemical reactions are the 4 listed here, but there are more, hence the question mark. What is another piece of evidence that I have that a chemical reaction has happened? I introduced to you a new experiment called Limewater. In the mystery mixture, we created a gas, and it was CO2 gas, like in Sprite. This time, we're going to add air or a gas to a mixture, and we're going to see what the chemical reaction result is. So we are adding lime water or calcium hydroxide located at the bottom. Calcium hydroxide is made of 1 calcium, 2 oxygens, and 2 hydrogens. Then we are going to add air or CO2 gas to lime water to see if there is a chemical reaction. We're not creating air, we're adding air.
Okay, in this investigation, we're going to use calcium hydroxide, which is a solid powdered substance. And we made a solution of that with water, and it has a common name called lime water. And what we're going to do, we put some of that lime water, which is the calcium hydroxide dissolved in the water, and put it in this little bottle here. And Ms. Gloss is going to blow into the bottle, and when she blows into the bottle, that's adding carbon dioxide. And the carbon dioxide is going to react with the lime water or calcium hydroxide. And after she blows into this a while, we should see evidence of a chemical reaction. And I can already tell it's getting cloudy. It was clear. Now it's cloudy. Wow, that was a big breath. Very good.
And it should show.
All right, so we're gonna let that settle a little while, and then we'll look at it again. Okay, here's the washing soda that Miss Kloss blew into. So we added carbon dioxide to it. It's been sitting here for about 5 minutes, and I'm gonna get closer and give the camera a second to focus. And you can see down at the bottom there where the little hose is going into it, you can see the solid at the bottom. Okay, that's the precipitate. As I move it around, you can see it kind of bounce around. So not only did this get cloudy after she blew into it, but it formed a precipitate. So we know that was a chemical reaction.
So to recap, we have a bottle of lime water that was more or less clear with calcium hydroxide dissolved in water. We added CO2 gas through a tube into the lime water through the lungs of the teacher, and little cloudy dots began to arise and sink to the bottom. The sinking to the bottom was called a precipitate, or a new substance being made that wasn't there before. Remember, the liquid was clear before, and she exhaled CO2 gas into the lime water, creating a new substance. That new substance is called a precipitate. It fell out of solution down to the bottom.